These are some of the questions asked in previous GATE question papers. It is asked in GATE 95. You can read about it in some paper also. Watch it. In a virtual memory system, so they are saying that there is a virtual memory is implemented. The address space generated by the address lines of the CPU. So what is the address space generated by the address lines of the CPU? That is logical address space, isn't it? CPU always generates the logical address, and the space generated by that logical address is called as logical address space, right? So in a virtual memory system, the address space generated by the address lines of the CPU must be. So they are saying that what is the relationship between logical address space and physical address space and secondary memory size in terms of virtual memory system. So in virtual memory system, strictly speaking, always the process size should be larger than the main memory size. Then only we are using the virtual memory. The entire concept of virtual memory is if the process size is too big compared to the main memory size, then we are going to load only a part of it and we are going to run it. That is virtual memory, right? Therefore, the logical address space which is generated by CPU is nothing but the process size should be larger than the main memory and it should be lesser than the secondary memory. Why should it be lesser than the secondary memory? If it is even larger than the secondary memory, obviously the program doesn't fit even in the secondary memory. See, secondary memory should contain everything, right? Therefore, the relationship between is they are saying that this is the address space generated by the address of the CPU, which means if they are talking about logical address space, therefore logical address space should be greater than the physical address space and it should be less than the secondary memory, right? Then only we can introduce this virtual memory concept. That is what is done initially, but later how this virtual memory got converted is, even if the process is not too big or not larger than the main memory size, still we are using virtual memory concept. The advantage of virtual memory concept is we are going to have only a part of the process to run the process. Now if I take only a part of the process to run the process, so what I was saying is, even though the virtual memory was initially introduced in order to run the processes which are larger than the main memory, later the concept has been used in order to increase the multi-programming environment. The reason is, even though the process are now smaller, that entire process could be kept in the main memory. We are not going to keep them, right? We are going to only use a part of the process to be placed in the main memory so that many processes can be kept in the main memory, which will increase the degree of multi-programming, right? So slowly we got converted. See, initially virtual memory is introduced to run larger process. Later virtual memory is also applied to increase the multi-programming environment. The reason is, if I use virtual memory, then I am going to put only a part of the process in the main memory. Therefore, many parts of the process can be present, or various processes can be present in the main memory at the same time, right? Okay. So for this question, this seems right. But then recently virtual memory size or logical address size need not be bigger than the physical address size, right? It is asked in 1995, but later nowadays we are having operating systems where even if the process size is smaller than the main memory, we are still using virtual memory concept. See, what I mean to say is this. Initially, when this concept of virtual memory was introduced, then people used to use this virtual memory mainly in this case when main memory size is something, let us say this is the main memory, and if the process size is something, right? Now the process size is bigger than the main memory size, therefore we cannot put the entire process here, so we cut it into small parts and only small parts will be kept here and they will be run, right? That is called virtual memory. And in that situation, the secondary memory should be, or the hard disk should be large enough to hold the process, right? And the process should be greater than main memory, then only we are using virtual memory. Later what happened is, even though our main memory is large enough to hold a process, let us say this is the process size, we are going to put only a part of the process in the main memory, because we can put many processes in the main memory and run all of them in a multi-programming environment, increasing the degree of multi-programming and hence the CPU utilization, right? So later slowly we moved on to virtual memory, or the application of virtual memory has been extended in such a way that it is now being used even when the process sizes are less. So that question was asked in 1995. During those times, people used to use virtual memory only when process size is very much bigger than the main memory size. But now we are using it even when the process size is lesser than the main memory size, because we can improve the degree of multi-programming. Right? Okay. Now, dirty bit for a page in page table. We know that. So what is dirty bit is, sometimes see this. Let's look at it in the light. Okay, I have to again explain it after some time, but let me do it here. It is not very difficult. Now let us say there is a process here, and the process is having two pages, and now one of the pages is loaded in one of the frame here, and let us assume that this process has got only one frame to use, and later when this okay, I'll just take it. Let us assume that this is the main memory, and main memory is having all these pages, frame number 0, frame number 1, and this is the process, and the process is having 4 pages, right? So assume that this process P1 is given frame 0 and 1 in order to run the pages, in order to run its program. Therefore, page number 0 is loaded in frame number 0 and page number 1 is loaded in frame number 1, and it is running successfully. And so what happens is, one more thing. In a process, there are various sections. The main sections are, one is code section, that code segment, and other is data segment, and other is stack segment. These are the three main segments: code, data, and stack. Code is generally read-only memory. People will only read the code, so they generally don't modify it, right? And data, that will be read as well as written. It will be modified, and stack, that will be modified, right? So whenever you are having some pages in the main memory, right? Let us say this process is allowed to access only these 2 frames. Then what happens is, in case if it wants to load page number 2, one of the pages have to be replaced, right? Then depending on that, you are going to replace a page with the other page. Then there is a problem here. By the time, let us say 1 is chosen to be replaced. By the time 1 is chosen to be replaced, if this page has been modified, then 1 has to be written back first, and then 2 has to be loaded. In case if 1 is read-only page, or 1 is never modified after being loaded, then you can directly write second page on first page without again writing back. That is going to save some time. So whenever you have to replace a page, right, if the old page has to be written back and then the new page has to be read in, it is going to take more time. In case if the old page need not be written back and the new page can be directly overwritten on it, then it is going to take less time. Just to make the difference, which means after loading the page, did we modify it? If we modify it, then we are supposed to change it. Then we are supposed to write back. That is called as write back. So just to remember, or just to keep track of whether a page has been modified or not, we are going to use dirty bit. If dirty bit is set, we are supposed to write back the page, and then we are supposed to read the next page. Got it? So that is the main advantage of that dirty bit. So dirty bit will be present in the page table entry that will indicate whether this particular page has been modified. If it is modified, then later when you are going to discard that page, you are supposed to write it back, otherwise the data will be lost, right? So that is the main advantage of dirty bit. Now what is that they are saying? Dirty bit helps avoid unnecessary writes on the paging device. Obviously it helps avoid unnecessary writes, but then I didn't really understand what do they mean by the paging device. I have never come across this word called as paging device, but anyway, dirty bit's main advantage is to help unnecessary writes, avoid unnecessary writes. What are unnecessary writes? If a page is never modified, you can directly overwrite on that, or you need not write back onto the old page. Okay, next one. A computer system supports 32-bit virtual addresses as well as 32-bit physical address. Now the virtual address space and physical address space both are same, which means the size of the process and the size of the main memory are both same. Since the virtual address space is of same size as physical address space, the OS designers decided to get rid of the virtual memory entirely. So what does that mean? They decided to get rid of virtual memory entirely means they decided in such a way that we don't want to load a part of the process into main memory and run it. That is what they decided. Are you following it? See, virtual address space, which means the process size, is equal to physical address size, which means the main memory, both are equal, and therefore we need not load only a part of the process, we can load the entire process and we can run it. So therefore they thought that we will not load part of the process, we will load the entire process and we will run it. That is what they are saying. Getting rid of virtual memory means what is virtual memory? Running only a part of it or loading only a part of it in order to run it, right? Which of the following is true? Efficient implementation of multi-user support is no longer possible. So once you load the entire memory with only one process, how can you support multi-user? Multi-user requires multi-programming, which means at the same time in the main memory there have to be many processes. But because of this, because you are using up the entire memory for one process, this is no longer supported. Yes, this is true. And next one is, the processor cache organization can be made more efficient. There is no relationship between virtual memory and then cache organization. This is wrong. Hardware support for memory management is no longer needed. Hardware support is needed. See, even if you use virtual memory or not, as long as you are using paging, you are supposed to use this memory management support from the hardware. You are supposed to use page tables. Either you use virtual memory or not, you are supposed to use page tables. Otherwise there has to be static or that load time binding. We cannot do load time binding when we want to move out the process and load the process, right? So this is false. Hardware support is always required as long as you have paging. Otherwise, if you go with the software support, it is going to take hell a lot of time. So hardware support is required for paging. Either you use virtual memory concept or not, right? So why should we go for a hardware why should we go for this hardware support is, we keep on moving the process around. Sometimes we will pull the process out and we again load a new process, and the next new process might not be loaded in the same page, same location. Therefore hardware support is always required. And then CPU scheduling can be made more efficient. There is no relation between this scheduling and then this virtual memory concept. So all are false. Only thing is, efficient implementation is no longer possible. Okay, fine.